Hey everyone, my name is Adam, and I will be your speaker today. Today's lecture will be a continuation of part 1 of logic and reasoning. But today, we will be focusing more on patterns. Let's do a recap of conditionals and De Morgan's laws. Remember that conditionals have 5 types. Conditionals are used to determine whether a statement is true and evaluate whether a conclusion can be made from the original statement. If the conditional is true, then the contrapositive is true. If the converse is true, then the inverse is true. If the conditional and the converse are both true, then the biconditional exists. So now, we will be moving into patterns. Patterns are a repeating form or design that occurs regularly. We can see it in waves, pictures, we could see it in the golden ratio in math. We could also see it in simple arithmetic sequences. Let's give a few examples of patterns in life. For example, when your teacher gives the class a test every Monday, that's a pattern because you know that in the future, all Mondays, you will have to take a test. That is a pattern because it happens regularly. The second is that TRA lectures are all using the same template. You would know that the next lecture will be also using the same template, simply because it's a pattern. As you can see in this meme, PewDiePie is also talking about a pattern, since these things have happened before, so we can predict that in 2021, something bad will happen. We now know that this is not true, which is why this is just simply a meme. Now let's try some problems regarding patterns. Can you find the next 2 terms? You get 30 seconds. Time's up. The first question, as we can see, is an arithmetic pattern. No, it's not a joke. The first problem we can see is that it's just numbers. So how do you determine the pattern? We look at consecutive numbers to see what the relationship between the former and the latter. So 1 and 3 have the relationship of times 3. 3 and 9 have the relationship of times 3. It's the same with 9 and 27. Therefore, we can predict that the next term is 27 times 3, and the next term after that is 81 times 3. As for the second one, we can see that it's just simply switching colors. If we look at one color at once, we can see that the green rotates in a clockwise fashion. Therefore, we can conclude that all the colors do the same by looking at the picture. Therefore, we can conclude that the 5th iteration would be the same as the first, because the green would just rotate back to the top left, and then the one after that would be just the next rotation. But the last one is just a trick question. This is not an indication of a pattern, just a joke. If 1 is equal to 5, 2 is equal to 6, 3 is equal to 7, 4 is equal to 8, then 5 is equal to 1, because as stated previously, 1 is equal to 5. Similarly, 6 will be equal to 2, since previously stated 2 is equal to 6. 5 is not equal to 10, because it has been stated. However, if you look at it in the pattern sense and do not look at the equal sign or any sense of math, then we can conclude that 5 is equal to 9. But wait, laws of logic are actually needed to find patterns in order to prove that patterns exist. So we use 2 laws. The first law is the law of detachment, which states that if P then Q is true, therefore if the conditional is true, and P is true, then Q is true. So if P happens, then Q happens. This is just logic. And the second is a law of syllogism, which states that if the conditional of P and Q is true, and the conditional of Q and R is true, then P, then R is also true. The law of syllogism simply extends the law of detachment to the extent that we can determine 3 statements at once. Let's look at an example here that we can see. So the first statement is that the person with the best grades is the smartest. Now, I know that this may not be true because usually it's the one who works the hardest. But let's assume that this is true. Bob has the best grades in the class. What can we conclude from this? This is the law of detachment because there are only 2 statements. So since the person with the best grades is the smartest and Bob has the best grades, then it must mean that Bob is the smartest. Logically speaking, that's true. And as for the law of syllogism, An example would need 3 statements. First statement is, once I turn 18, I will become an adult. I will become an adult is the second statement. And adults will need to look after themselves, since they need to be independent. This is the third statement. So using that, we can conclude that when I turn 18, I will need to look after myself, because when I turn 18, I will become an adult who then needs to take care of themselves. It seems pretty simple, and it is. But it is important to note that using these laws are essential to proving some theorems, to proving other things that you want to prove is true or false. Let's do one practice question on the topic of the laws of syllogism. If you do not study, then your grade will suffer. If your grades suffer, then you will not pass the course. What can you conclude? You'll get 30 seconds to answer this question. Time's up. So we can see that you do not study is the P, your grades will suffer is the Q, and not passing the course is R. So if P then Q is true and Q then R is true, then P then R is true according to the law of syllogism. Therefore, we can conclude that if you do not study, you will not pass the course. Of course, in real life, there are exceptions, but using statements that are objectively true, we can determine the validity of a statement using logic and reasoning. Thank you for watching this lecture, and we hope to see you in future videos.